Okay, Algebra 2, section 10.3 is on probability and odds. Basically, the definition of a probability is the likelihood of something occurring. Okay, so it's the likelihood of something occurring. It's always a number between 0 and 1. If the probability of an event occurring is 0, that means that that event will not occur. If the probability of an event is 1, then it means that that event is most certainly going to occur. Now, probabilities are often written as decimals, as percentages, and as fractions. Okay? Sometimes they are written as ratios, but that's extremely rare. Okay? So probability is the likelihood of an event to occur. Now, the theoretical probability is calculated. The probability of some event is calculated in the following way. It's the number of outcomes of an event over total number of outcomes. Okay, that's how you calculate the probability. An example of that would be, let's say I have a deck of cards. A standard deck of cards has 52 cards. Now, the sample space for a deck of cards can be found in section 2. And you can look at that to help you. I believe it is on page 690. Okay, let's say I want to calculate the probability of selecting a red card. Well, in a standard deck of cards, 26 of them are red. Out of a total of 52 cards, reduce that fraction, my probability is 1/2 or 50%. Okay? So far, so good. Now, sometimes we will need to use combinations to calculate probability. All right? So if you'll look at example 2 in your textbook on page 699, that's an example of where you would have to use a permutation or a combination. Actually, it's not you won't use permutations. You'll always use combinations when you do this. All right, so we've got a place that's hosting a talent contest, and on one evening, 7 musicians, so a total of 7 musicians, we got 7 musicians are scheduled to perform. The order in which the musicians to perform is randomly selected. What is the probability that in part A, what is the probability that the musicians perform in alphabetical order by their last name? So, what's the probability that they're all in alphabetical order? Well, there's only one way for them to all be in alphabetical order, and there's 7 factorial possible ways for them to be lined up. Which is 1 over 5,040. There's a 1 in 5,040 chance that this will occur. Suppose you have two friends. That are performing. Actually, according to this example, it says suppose you have 4 friends that are actually in this talent show. And of the 4 friends, what's the probability that the first 2 performers are your friends? Well, probability the first 2 are your friends. You have 4 friends, and 2 of them will be the first 2. There are 7 people total. And there's 7 C2 different combinations of 2 performers. This will be 6. This will be 21. We reduce that fraction. That'll be 2/7. All right. So that's how you calculate probabilities. Another way of dealing with probabilities is the idea of odds. The odds in favor or odds against. Now we define odds in the following way. First of all events must be equally likely, okay, to calculate the odds. So the odds in favor of an event occurring is calculated by doing the number of outcomes So the odds in favor of event A are the number of outcomes of A over the number of outcomes not in A. Odds against, we just reciprocate this. If it's the odds against A, then we would say the number of outcomes not in A over the number of outcomes in A. So, for example, I want to do a probability and an odds question at the same time. Suppose I'm rolling a standard die. Okay, it's got 6 sides with dots representing numbers. 1 dot represents 1, 2 dots represents 2, so forth, so on. So we got 6 sides, so we go 1 through 6. What is the probability that when you roll a die, you get a 5? Well, the probability is that there's only 1 5 out of 6 total. That's 1/6. Okay, now let's talk about this. What are the odds that you roll a die, 5? Well, the odds are the number of outcomes of A, there's only 1. Five. The number of outcomes not in A is 5. So we say the odds are 1 to 5 that you roll a 5. That's how you calculate the odds. All right, let's look at another problem involving odds. Let's go back to our standard deck of cards. Suppose we have a standard deck of cards and we want to do a odds in favor of of choosing. I'm picking cards, not rolling cards. Odds in favor of choosing an ace. Odds in favor of choosing an ace. Well, how many aces do I have? I have 4. How many non-aces do I have? 48. So my odds are 1 to 12. Now you can leave it in fraction form if you want. Most times we write probabilities in fraction forms, but you can put them in this way. Now probabilities are fractions, decimals, or percentages. Odds are always written either as a fraction like this, 4 to 48, or 1 to 12. Okay, this is the only way we write odds. For probabilities, we can write a fraction, a decimal, or a percentage. It makes no sense to do that with odds. There is another type of probability that's in your textbook, and that is an example of a geometric probability. Now, the geometric probability means that you will need to be able to calculate areas of certain things, like circles, rectangles, and squares, and triangles. So you need to be cognizant of that. Example 5 in your textbook is an example of geometric probability. All right. So if you'll look at that example, it says you're throwing a dart at the square board. The square is 18 inches on each side. Your dart is equally likely to hit any point inside the board. Are you more likely to get 10 points, or are you more likely to get 0 points? In other words, calculate those areas. Well, the area of a square is 18 inches. So the area of the square is 18 squared inches. The 10-point circle has a radius of 3. So the probability of 10 points is the area of the circle with 10 points in it, which is pi times radius squared, which is 9 pi, over the area of the square, which is 18 squared. Now you could convert this to a decimal and you'd get 0.0873. The probability that you get 0 points would be the areas of the little edges of each corner. Now to find that area, you would take the area of the entire square, subtract from it the area of the 3 circles, which is going to be 81 times pi, because the radius of that of those three circles added together is 9. 9 squared is 81. And then we divide that by the area of the entire circle. Use your calculator to calculate this. You would get 0.215. So this is 8.7%, 8.73 if you want to do it that way. This is 21.5%. So which one's larger? So you are more likely to get 0 points than you are to get 10 points. The other idea is experimental probability. Experimental probability is where you're given data from an experiment, typically in the form of some type of graph or table, and you do probabilities based on that. An example of experimental probability is on page 700, and it's example 4. They give you a bar graph, and they ask the question, find the experimental probability that a randomly selected adult would prefer to be at least 40 years old. So first of all, you have to find the total number of people surveyed by adding up each column. That's 3,516. Of those surveyed, people who would prefer to be at least 40 would be 551 plus 300 plus 238, the last three columns. And that total is 1,089. So the probability that a randomly selected person, at least 40, would be 1,089 over 3,516. That comes out to be about 31%. So the probability that a randomly selected person would want to be at least 40 would be 31%. All right, so this is how you deal with probabilities.